In this video lesson, we will learn about inscribed angles. So first I'll explain what an inscribed angle is. What we're talking about is circles right now. So let's say we have this circle. Then first, before we talk about the inscribed angles, I'll mention minor arcs. There's also major arcs. And between A and B here that I highlighted, the smaller part is called the minor arc, and it has a measure in degrees, and that is that measure in the center of the circle. So arc AB, minor arc AB, is said to have measure x. So that is what we mean by the measure of an arc. And of course, this measure can only go up to 360 degrees because the circle is at most 360 degrees. 360 degrees is all the way around. And we usually label it like this, x degrees on the outside. So as I said, 360 degrees is the most possible. The major arc that goes the other way around would be 360 degrees minus x degrees. That would be its measure. So now that we know what an arc is measured, how is it measured, it is that central angle. Now we can talk about inscribed angles. An inscribed angle is when you have 3 points like this on a circle, and one of these points is the center of an angle. So A is the angle A. Then there's a special theorem that if the arc BC, opposite of A, has measure x degrees, then the measure of angle A is x degrees over 2. So that is the theorem that we will talk about. And now I'm going to apply it to a few problems so that we have a better idea of what's going on. So here we want to find the measure of angle ACB. So that's that angle. I'll label it as x degrees. And we know that the measure of AB is 115 degrees. And since the measure of AB is that arc that the inscribed angle intersects, then the measure of that inscribed angle is half of 115. So we divide by 2 and we get 57.5 degrees. So once again, it's that arc opposite of the angle. And that there I just showed how we define this arc measure. So now let's do another example. Here we want to find the measure of angle D. So before we can find the measure of angle D, because right now it's not obvious how to do it, let's try to find out what we can about this situation. So we know the 45 degrees, and that 45 degree inscribed angle, it intersects this arc. This is the arc opposite of the angle. So right now what we can say is something about that arc. Our theorem tells us that the minor arc BC has measure equal to twice times the angle of A. So we multiply 2 times 45 degrees and we get 90 degrees. So that's the measure of arc BC. Now we can look at D, and look, D, the opposite minor arc from D is also BC. So the measure of angle D is half of BC, so it's 45 degrees. So the answer is 45. And you might notice this is actually the same as angle A. And the reasons for that is because we first multiplied times 2 and then we divided back by 2. In fact, you might notice, this is just the additional fact, that since B and C intercept the same arc, then angles B and C are also equal to each other, not necessarily to A and D. But anyway, that is a useful fact to know. Now the last problem. Find the measure of angle ABC. So it's this angle. And I'll label it as x degrees. So what can we say about x degrees? So the intercepted arc AC, it looks like it is a minor arc, but the measure of this intercepted arc is 2x by the theorem. We also know that 2x degrees, because combined with the other angles we have a full circle, all these summed together is 360 degrees. So 2x plus 70 plus 120 is 360 in degrees. So we simplify this. 2x plus 190 equals 360. 2x equals 170. When we subtract 190 from 360, we get 170. And then we just divide by 2 and we get x equals 85 degrees. So the answer is 85 degrees. And I'll just rewrite it better up here in a box. Angle ABC equals 85 degrees. So I hope this helped, and thank you for watching this video lesson.